Hey everyone, welcome back. Today we will be getting to know trigonometry. This is a triangle. It has 3 sides and 3 angles, and the angles of this triangle and every other triangle add up to 180 degrees. To label the sides, you label each side with the lowercase letter of the opposite side. So for this side right here, it would be lowercase x because x is the opposite letter from this side. For this side right here, it'd be lowercase y because uppercase Y is the label of the opposite vertex. And then for this side, it would be lowercase z because capital Z is the opposite. There's also another common way to label sides. You can use the capital letters of the 2 vertexes the side connects with. So for example, this side could also be labeled as x, y in capital form because x and y are the vertexes of this triangle. And then for this side, we can call it y, z, uppercase. And then this side, of course, it'll be x and z. This is just an alternative way you can use to label the sides of this triangle. In trigonometry, the side of the triangle opposite to the 90-degree angle right here is called the hypotenuse. The hypotenuse is always the longest side of a right triangle. So in this case, the hypotenuse would be this side right here. The other sides are known as the adjacent and opposite, depending on the relationship to the angle of interest, which we use theta to describe the angle of interest. So in this case, it is important to note the opposite and adjacent can change if the angle of interest changes, but the hypotenuse remains constant. The side that is the opposite to the angle of interest is called the opposite side. In this case, the side that is opposite is this one. So we can put op as a label, and the remaining side is called the adjacent. Right now, labeling it is pretty useless, but once we figure out how to use trig ratios, then it'll be very important to find out unknown sides and even angles. The Pythagorean theorem is very important in this unit, so it'll help us find the lengths of sides in a right triangle. The formula for the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and a and b could be either the opposite and adjacent side of a right triangle. Right away, we know the hypotenuse is the side, this side, because it is the opposite to the 90-degree angle. So this is our c value, which we need to find out. So a could be either 3 or 7, it doesn't matter, and we'll just put 7 in place of b, and that's our formula. So what we can do is 3 to the power of 2, we can solve this, which is 9, and we can add 7 to the power of 2, which will be 49, which will still equal c squared. And so 9 plus 49 will equal 58, and 58 equals c squared. And to isolate c, we need to use a square root to get rid of the square. And after we do that, we'll end up with c equals 7.615, and we can round that out to c equals 7.6. So the missing side is 7.6. I'll give you one more. We have a triangle like this, and we notice that the hypotenuse is already solved. So we're solving for this side right here, and we'll just call it the b value for now. So we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, and we can just plug in what we already have. So 3.9 squared plus b squared, which is the unknown value we're trying to find, and c squared, which is 11 squared. After we do that, we can use a calculator to find out that this is 115.21 plus b squared equals 121. And now we realize we have to isolate the variable, which is b. So to do that, we can subtract this from both sides, like that. This cancels out, and we're left with b squared equals 105.7. And to isolate the variable, we just put a square root to get rid of the square, and we're left with B equals 0.2854 after we put it in a calculator, or we can just say B equals 10.3. So that is the missing length. And that's all. Thanks for watching, and I'll see you later. Bye.